Okay, don't watch that.
All right, so a scatter plot is a graph of points as a collection of ordered pairs. And basically, the graph looks like a bunch of dots that are in the graph. The graphs are a shape from the survival functions. The graphing calculator gives you the correlation coefficient, which is R, and some of them don't have R, they just have R squared, so technically R squared is not the correlation coefficient, but we're gonna say R squared, okay? It's called something else, it's called the, I don't know, it's called something crazy. This number tells you how closely the equation models the data. The closer the coefficient is to 1 or -1, the more closely the equation models the data. When choosing which regression is best, pick the correlation closest to 1. We want that number, when I say closest to 1, I don't mean like 0.89 or 0.97. I mean like 0.9999999. Okay? I want it to be a bunch of nines in a row. Okay? You don't have that page, do you? Sorry. I don't know how you don't have that page. I must have pulled it out of a couple of them. Now, you'll notice there's no more spaces to fill in the next part because I don't want you to mess it up. So there is the calculator steps for regression, and then there's the steps for regression in Desmos. So we're going to talk about both of these, and then we're going to go do them, okay? So let's talk about the calculator steps for regression. This is your TI-84 calculators, your handhelds that you have in class, or some of you might have, I've noticed that several of you have them here in class, okay? So the first thing we want to do is, there'll be times when they tell you which regression equation to use, okay? And then there'll be times when they'll say, pick the best model. When they tell you to pick the best model, then you're going to need to create the scatter plot and look at it. Now, when you're creating the scatter plot and looking at it, you need to remember what the shapes of our survival functions look like, okay? Remember that linear is a line, quadratic, U, quadratic is a U, cubic is that cube that's like that weird graph, absolute value, like V, the value, square root is that nice swoop, exponential grows exponentially, okay? So you gotta know what your graph shapes look like. That's why we do the survival functions first, so that you can figure out what those graphs look like. So once you know what the graph shapes look like, and maybe you want to draw them over here so you know what they look like. But once you know what the graph shapes look like, then you decide from that. But in order to turn your scatter plots on, first thing you're going to do is you're going to go to y equals for your scatter plots. You're going to go up to plot 1 and hit enter. And then once you do that, you don't have to do it anymore. Okay? Once you turn your scatter plots on, that's done. Then every time you want to look at your scatter plots, all you have to do is hit zoom 9. Okay? Because zoom 9 will always zoom to the statistics. Okay? And it'll always show you the shape of the graph. Now, this is the best part, one of the best parts about using your calculator versus Desmos. In Desmos, you can pinch and you can move and do all kinds of stuff. But depending on how you zoom in, you might not be able to tell the shape. You might think it's linear when it's really quadratic. You might think it's quadratic when it's really exponential. Because this graph in your calculator is always going to come in and make it pretty, okay? And fit it just right in the graph so that you can see the shape good. All right? Now, when we're putting in our calculator, there's all these steps. But you'll often hear me say stat edit, stat count, number, whatever, alpha trace. Stat edit, stat count, number, alpha trace. Now, depending on what kind of line we're doing, that's what number we're doing. okay? Stat edit, but all these stats bog down into stat edit, stat count number, whatever, alpha trace, okay? And here's our numbers. Number 4, number 5, number 6, number 0. Number 4 is linear, number 5 is quadratic, number 6 cube. And when we go to our calculator, you see it says ln, quad, cube, x. So you'll be able to tell which one is the right one here, okay? And the alpha trace is the y1. That's where we get y1. And we're going to store that, put that in store regu cube, okay? That's the regression equation. We want to store the regression equation in y1. And y1 is in alpha trace. That's why we say alpha trace. Okay? Now, I go down and I give you all these equations of the lines. Now this, the calculator is going to give you these equations of the lines, but I give them to you here because you need them for here. If you don't know them up here, no problem, because your calculator didn't say. The problem is you need to know them for decimals. So if you don't know them for decimals, I give them to you, okay? So the equation y equals ax plus b is linear. The equation y equals ax squared plus bx plus c is quadratic. The equation y equals ax cubed plus bx squared plus cx plus d is cubic. The equation y equals ab to the x, remember x has to be an exponent to be exponential. And all you're doing is plugging in a, b, c, and d. Now, there's going to be times when your calculator or your problem says to estimate. Okay? Using a model, estimate, whatever. And when it tells us to estimate, we just do y1 of the number 1. We use that function notation. So y1 of, so y1 parentheses. And remember, y1 is alpha trace. So we would do alpha trace. And then parentheses of the x, okay, that we get. Questions? All right, so let's go do number 1. So here's our, everybody got that? So let's look at problem number 1. It says, find an equation for the trend line. They're basically telling it, they always call it a line, so we're going to assume that it's a line. And the x is going L1 and the y is going L2. So we're going to go right to our calculators. We're going to hit stat, which is right here. Edit, so we hit enter. Now, if you have stuff in your calculator, arrow up, hit clear, not delete, but you delete the list, and arrow down. You don't want to delete L1 and L2, you want to clear it. Arrow up, hit clear, arrow down. Now put the data in. So our data is 6. Okay. Everybody got the data in? I'm gonna come check you in a minute. I hope everybody got it. Yes? All my numbers there? I lost them. Yeah. Look at this. So zero. Yeah. So. Something's wrong with my, what am I missing?
Added 9. Like 9 is not part of the graph.
It's supposed to be 6, 7.
10.
Yeah, just 6, 7, and 10.
Thank you. I knew something wasn't right. I couldn't figure out what it was.
How do you get rid of a number?
Like completely, just hit delete on
Like
top of
what
the
you just
number.
did? You hit what?
I typed over top of it. If there's one too many numbers, just delete it. If it's just in the wrong place, like mine, I didn't have too many numbers. I just needed to change it. I just typed on top of it. Just arrow on top of it and type it.
So what'd you change the 9 to?
A 7.
Oh, okay.
It should have been 6, 7, and then I think I had 7, 9.
But do you delete numbers?
Just hit delete on top of that number. So like if you have 5 in one row and 4 in the other, just hit delete on top of that one. And if you have I noticed I did have 276, so I inserted a number.
Yeah.
So you can insert a number or delete a number. Okay, everybody with me? So stat edit. Let's go turn the stat plot on and look at it. So go to y equals, arrow up, hit plot, so that it's highlighted, and then hit zoom 9. So if we were to draw a shape, this is not really a nice shape. We probably could draw a line in there, probably. It's sort of linear. It's not great, but it's not a bad line. So, but we can find out. So let's go stat, calc. Now which one says linear? 4. It says it right there, right? Our notes say 4, and there it says linear right there. So stat calc number 4. Now we want to store the regression equation. That's our alpha trace part. So go down right here to regression equation and alpha trace. If we alpha trace here, y1 will come up. So we hit enter. Now you should be here. Everybody with me?
I got a question. Earlier when we went to the graph,
Just hit it one time. Go over. Yeah.
whenever we went to the graph, earlier, I did this, I hit zoom 9, correct? It didn't show up any points.
Because you didn't have it on. Turn it on. It probably was already on. Okay. Everybody with me? Okay. All right, so here, let's calculate. Let's make sure we're all making the same thing. Make your say enter. Do you have this? Arrow up. Hit enter on the plots so it's dark. Zoom 9. Okay. Now stat calc. Number 4. Go down to regression equation. Alpha trace. Alpha trace. Enter. 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 Okay. Woo, why don't mine look like y'all's? Something's wrong, something's wrong.
I got 13.6.
You see?
Is that?
You did 276.
I see it, I see it. How about that? Ha
Yeah, the R.
If you're using your calculators, go to mode. Go down to the second screen, it says stat diagnostics. And turn them on.
I don't know how to get to.
You see it?
I don't know how to get to where you are.
Hit calculator. Go down, hit calculator.
Oh, dang. What I do?
Swap, turn, arrow up. And your plots on, zoom in. That's the good. Okay, now step up. Stat. Over to that. Over 4. And go down to your equation. Alpha trace. Enter. And go down to calculate. Enter. Ready, match me. Everybody got what I got? Anybody not got what I got? Yeah. Nothing. Stat. That's right. Go stat. Now draw your line. Calc. Over the calc. See how it's good. Stat. Calc. Number 4. Go right here. Store right here. Alpha trace. Number 1. Yeah. Calculate. Everybody got it? Everybody got it? Now, it should give you, now, everybody good. Okay, so, now, it's giving you an A and a B. And it's told you the equation of the line. So now we have to go write this line down, okay? So, we're going to use 2 decimal places. It says round to the nearest, I don't know what it told you, but we're going to round to 2 decimal places. The nearest hundreds, okay? So what would we write here? Y equals 13.61. So we're going to go over here and we're going to say Y equals 13.61. And it says X. Don't forget X. So we're going to write X plus B. So B is 150.87. So plus 150 0.87. Okay? So when it asks you to write a line of best fit, that's the line. Not Y equals X plus B, A equals B equals. The line is Y equals 13.61X plus 150.87. Okay? Now, it says estimate, where's the word estimate? For 14 grams. So they want us to find Y1 of 14. Okay? So we're going to go back to our trusty calculator. And we're going to put, how do we find Y1? Alpha trace. There's Y1. That's telling me my equation that's in Y1, put 14 into it. Your calculator will do function notation for you, okay? You just have to tell it that. That's what the parentheses are for. If you don't use parentheses, it doesn't know that you're wanting to do function notation. So Y1 of 14, there it is. 341.37. So 341.37 calories. Okay? So we're going to come back to number 2. Let's do number 3. So number 3 says find the quadratic line of best fit. They tell us it's quadratic. So we're going to go put this data in right now. So back to our calculators. Stat, edit, clear the list. So arrow up, hit clear, arrow down. Arrow up, hit clear, arrow down. So stat, edit. Arrow up, hit clear, arrow down. Everybody with me? 2, 3, 4. I think those are the numbers, right?
Yeah.
Somebody tell me what the other three are.
Oh, my.
3, 13, 29.
3, 13, and 29?
Yes, ma'am.
Is that down?
Yeah.
Okay, everybody got the data in? Everybody with me? You with me? Okay. So let's look at it. Zoom 9. If it asks you to draw a scatter plot, that's all you do in your calculator. Zoom 9. There's only 3 dots. This could be anything. This could be linear, quadratic, could be exponential, could be anything. There's not enough dots to really tell, but they told us it was quadratic. So stat, count right here. So arrow over. Which one's quadratic?
5.
It says, look, it says quadratic. Number 5. We're going to store that regression equation. So alpha trace, enter, and calculate. Everybody get this? Show me. Stat. You're in the wrong place. Yep. Did you get it?
Yeah, but my very last part I put in storage, so it's messed up.
Do stat. Calc. 5. Store the radius right here. Alpha trace. There you go. Everybody with? So what's the equation we're gonna write? Y equals 3 x squared not plus
-5
minus 5 x.
Plus 1.
Right, we're not gonna do no double sign. Put that crap. Thank you. We don't like double signs. Y equals 3x squared minus 5x plus 1. We're mathematicians. Mathematicians don't do double signs. We're not doing that crap. Now it says estimate for x equals 10, right? So we want y1 of 10. Everybody tell me what y1 of 10 is. Alpha trace. So alpha trace y1 of 10. Now, if you don't get this number, you forgot to do the alpha trace on the last step, okay? So if you don't do alpha trace every time on that start reg EQ, it's gonna pull it up from the equation before, okay? So that's why you always wanna store the reg equation, because otherwise when you estimate, it's gonna use the old equation, all right? So 251 is your answer. Questions? One more. Number 5. So the company table shows find the exponential regression. All right, so let's go put this data in. Let's find the exponential regression. So stat edit, arrow up, hit clear, arrow down. Arrow up, hit clear, arrow down. If you should delete your list, if something should happen and L1 and L2 go away, when you do stat, let's do number 5. The list will come back, okay? I know this part. I don't know what's over here. But I know that part.
You want me to tell you all the
All right, y'all ready? Yeah. All right, y'all start calculating. I'm gonna zoom 9 so y'all can see what it looks like. So this is a nice exponential curve. Some might say it could be a quadratic curve because it could come back around and come on this side. It is a nice exponential curve, but let's start calculating and see what happens. So you obviously we know it's 0, but if you're not sure, you could go down through here and say, this is logarithmic. We don't use this Lin reg. That's more of a stats thing. I don't know why they do it backwards because it's sorry, I don't know anything about statistics. And there's the exponential. And then we're going to store the regression equation because we always do. Sometimes we don't need it, but it's always good to have it in there. And then we're going to calculate. Did you get this?
Yes.
Everybody with me? Somebody's like, no? Okay. Now, you notice it says A times B, your calculator can't do X and the exponent, but they do the little caret key here. So we're gonna write 276.67. And it's probably better to put this in parentheses, but you can put a time sign there. And then 1.21 to the X. It's an exponential. X has to be in the exponent to be an exponential. All right? Now, it says estimate, there's our favorite word, the year 2005. Now, did any of these say like 1999, 1985? It says since 1984. That's my 0 year, okay? So if there's a 0 year, normally we would subtract that from whatever the years are that are given, but they've already done the subtraction for us. So we want Y1 not of 2005. We want Y1 of 2005 minus 1984. Now we can enter it just like that. Our calculator will find it for us because it's really good at math. I mean, it's a calculator, like all these. Or we can figure out what 2005 minus 1984 is, which happens to be Y1 of 21. Either way, you enter it either like this or like this. Your calculator will find the answer. Tell me what is the answer. It's something big, like 14,000. What's these three numbers in here? 387. Did you all get that? Yes? No?
My decimals were off whenever I did it. I didn't get like 6, 7.
Then maybe one of your numbers is off. I'm fairly certain that's correct. Did y'all get what I got? Or did you get something? Usually I just check right here to see if my number's match right here. Then I know that everybody's on the same page. Did everybody get that? Okay. Now, notice this says thousands of dollars, right? So this is $290,000 and $320,000 and $400,000. So this is in thousands of dollars. How do we express this in thousands of dollars? Wouldn't this be this instead of a decimal? And wouldn't it be this? So in 2005, the average salary for baseball players was $14,387,220. I don't know about you, but I wish I played baseball. Because I don't make nothing like that. Not even close. I don't make a tenth of that. I don't make 1% of that. I don't make, I can't even go into it. Questions? All right, so get out your devices. Let's look at how Desmos does this differently, okay? So we're gonna do problems 2 and 4 in Desmos. All right? So get out your devices. and just go to desmos.com. Desmos.com. Just type in desmos.com, and when you type desmos.com, at the top it says graphing calculator. If you just, if it's Googling, it'll say graphing calculator, okay? Desmos.com. So everybody pull up Desmos on your, yes, on your devices. If you have the app on your phone, you can do that. Either way, you can use the app on the phone or your computers. Where's your computer?
You give me the login for my phone.
Okay. Got it? Well, let's use my computer. All right, you ready? So, on our Desmos notes, let's look at those real quick. So on our Desmos notes, it says to enter data, we do plus the table, and then we write the equation on the second line. So we use this symbol instead of equals, and then we put y1 where y goes and x1 where x goes. Okay? And we use these equations that we have up here. All right? And if you watch my video for this lesson, it didn't do it for me in first period, but I realized that I said y1 and x1, and my table had 2's in it for one of them, and I couldn't get the right equation because I didn't notice the table had 2's. So if the table says x2 and y2, then it would be x2, y2. I'm just telling you that because sure as the world, it won't come out right, and you'll be like, why didn't this work? And that would be why, okay? So, let's go back to this. So we're doing problem number 2. So it says, problem number 2, it says the line of best fit. Now it says, let 1990 be x equals 0. So this one has a 0 year. That's our 0 year, right? So we do the year minus the 0 year here. Okay? So 1993 minus 1990 is 3, right? And then this would be 4, 5, 6, 7, 8, 9, 10. So those are the numbers we're going to put in. All right? So we go to Desmos, and we go in the corner and we hit plus, and we hit table. And we're going to put those numbers in. 3, 4, 5, 6, 7, 8, 9, 10. And then in Y2, all right. Everybody got the data in? And if you're in your computers, you can type on your keys. You don't have to like push the buttons on it. You don't have to like mouse it. You know, like I typed them down here. You can actually type the numbers. That's a lot easier this time. And here's where I just pay attention to what numbers are here. Like I think my second problem I did in my video, this was x2 and y2, and I didn't notice it until about 15 minutes in, after I worked on the problem for 10 minutes, I was like, why isn't this working? Like I talked to myself for 10 minutes trying to figure out why it wasn't working. When I did it in, my calculator came back, still couldn't figure out what was going on. Then I figured out these are twos and then I was like, oh, that's great. All right, so you know that it's linear, so we say y1, and I call this tilde, but it really is about approximately, okay? And our equation of a line is ax plus b. So we say ax1 plus b. Your calculator immediately gives you r and r squared, and it gives you a and b. Okay? Now, here's the thing it does not do. There's no zoom to the statistics. You have to go find the statistics. Like, they're there, but you got to like go find the dots to zoom. So there they are. 1, 2, 3, 4, 5, 6. There they are. The red line, see how it's red, is this line. And you'll see that those are green, that's why it's green up here, are the dots, okay? So the zoom is off based on how you zoom. Like I'd want it to be like more this way. But I can't get it to be what I want it to be. So anyways, okay? So there's our equation, y equals 32.33 x plus 238.38. Now this one doesn't tell us to predict, but had it asked us to predict, let's say it asked us to predict for 15. Okay? In Desmos, predicting is a little bit different. There's no y1 of. So you have to actually put x equals 15 in here. So if we put x equals 15, it'll draw this another line here, and you have to find where those lines cross. So now I've got to find the place where those two lines cross and find the intersection. There it is. Okay? So the answer is 723.33. Okay? The other thing I could do is I could just say 32.33, and everywhere x is, I could fill in 15. Now, you're going to see that that's not going to come out the same. If I go back over here and I type 32.33, I get 723.28. Well, that's not the same number I got, is it? The number I got before was 723.33. So plugging it in and finding where they cross are two different things. This would be a y1 of. Okay? So this is what happens if it doesn't round. This is what happens if we rounded things. And so that's the thing about rounding. Depending on how many digits you round, it's going to depend on how that thing comes out.
Hey, you got a purple charger?
No.
Or any of y'all got one? The old one?
All right, let's put in number 4. All right, let's go do number 4. It says with a quadratic function. So let's go back to Desmos. So So we just X all this out. Add table. Got it? What's the equation we're gonna use for quadratic? Ax squared, right? So ax1 and then square root plus bx1 plus c. Now, our dots aren't way up here now, our dots are way down here now. There's our parabola. Let's see if we can find our points. There they are. Look how pretty that is. Did you get that? All right, so let's go write our equation. So we get y equals 0.009x squared minus 2.10x plus 1.33. Yes? Now it says estimate the order for 35. So if we go back to our Desmos and put in x equals can we see, yes we can, where those cross? The cross is at 57.938. Yeah,
I don't understand, like, it's not showing up whenever I type in the what it takes everything down from the graph.
there's a lot equals. You have to do this thing. There you go. Yeah, not the equals, but the approximately tilde. I call it tilde because that's what it is in Spanish class. Yeah. Okay, so let's go back.
That does not.
Oh, that, I knew that. Okay, so out front, type Y1. And then go here, ABC, and this thing right here. And then this should have a 1 on it. So put a 1 there. There you go. Everybody good? Because Yeah, by one and X2. So make sure those are ones. Yeah, if those were twos, then that would be 2 and 2 or 1 and 1s. They gotta be the same one, whatever it is. That's it. Just tap where they cross. Numbers are off. Change that number and fix it. See it? Questions? Everybody got it? Everybody good? So just tap where they cross. Well, you don't have the line. This should be not, this should be the funky, this symbol. There you go. If you're not getting this graph, it's because you got to use that symbol. Okay? You can't use equals, you can't use line. It has to be that symbol. And that's found right here in ABC, right here. Okay? Questions? So, there's about, like I said, about 14 regression things that you have to do. It's like it's 6 pages of homework over 2 days. So if you have a calculator, you can use a calculator. If you have Desmos, you can use Desmos, whichever one. Desmos, you can just type desmos.com to go to it on your computers. Also, it's in your Canvas. So if you go to the resources in your Canvas, it's built into your Canvas. So you can just go into your Canvas and you can get to it in your resources, okay? So either way, to get to Canvas. Sometimes it's better like to get the Desmos app on your phone. So that it's like you can do it like over here with one thing, and then like you have like when we were doing some things, like some people were like the piecewise things, they were doing the piecewise functions in their phones and then looking at the graphs in their computers, so they could do that matching, like the matching slides. Because it's an easy app to have on your phone, okay? Questions? Any other questions? Okay. So I'm gonna see if the printers have come up and see if I can print you some more things. So one more thing I wanna show you, I'm gonna stop this. It probably been stopped, oh no.